Buti na lang, kasimula ko lang, no? Thank you, no? Al-Qaeda, and what's that? Anyway, thank you, everyone. So let us record this, no? So in any programming language, no, certain programs will require to make decisions, no? Okay, so branching is always important. Like the example we had in the analytical engine, where we try to find out whether a computer grade is passing or not. Okay, sometimes it's difficult to understand the logic there because it's a very crude language, no? So let us compare it to standard C++ or standard Python. Okay. So first, what you do is you declare variables, right? Now, in the analytical engine, right away we have variables, no? And we don't have data types. Here we have data types. Unlike in Python, they don't have data types also. So we are declaring three variables: float, S for score, I for items, and B for base, and G is for the grade. Okay, you can put it in one line. Okay, then we ask for the values using C in and C out. Enter a row score. Okay, and then we enter items, we enter the base of conversion. We can run it here. If you want to start again, you can just clear. No? Are you using this? 60, 100, and the base of computation is 40. So just write goes like that. No? And then the next thing to do in our program is to compute for the grade. And the grade is and output it. No? This is the way to output a float. Okay, output a float in C#, in C++. No, we computed the grade and we output the float. Kasi yeah, std and L, which means we use the standard rounding off, no, to compute the float. Okay, this will fix, no, the decimal places. Okay, and then let's run that. So this now computes the grade. And base of computation is 4. So your grade is 76. No? It computes the grade. Can you see that, everyone? Claro ba? Okay. So are you doing this already? Not yet. So, and then we will make an if then else statement. Pala yung aking ano, no? This is how we did it in ano. Is greater than 74.99. This is how we did it in ano, in the analytical engine. Do you follow? So the if then else here is a branching application. Okay, which is usually common in most programs. No, tan is right. No, that's common in most programs. No? Okay. So let's clear this. Let's run this again. No? So if you have 60, 100, and the base is 40. Okay, so it declares a decision. No? You run this again. So let's say you have 30. Okay, also 100, and the base of 40. So you have a failing grade. Okay, in that case, let me create in quickly, no, the Python compiler, no, the Python equivalent. So grade computation.py. So who among you are doing Python? So this is much easier, no? Because Python is a typeless language, and then there are no braces. No, you just indent. So S is, we don't declare variables in Python. Okay, so however, when we use input, automatically inputs are converted into strings. So we need to use an int converter, okay, for score, items, and base. And then we need a float converter for the computation of grade. Remind me later, no? Because I'm in the middle of ano. So this is the same formula. We don't have semicolons at the end. And then we print the grade using the print command. Okay. And then we declare a decision. Okay. Let's run this. 60. Okay. 60. 140. So it makes a decision. Okay. We can run this again. Okay. We have 30. 100. Okay. 4. Okay. So it makes the decision. In our Excel, so downloads, I think it's in the downloads. No? Here's the grade computation program we had. So ito yon. Do you follow? Okay. What we do is first, I've introduced this to you already. Okay. Divide the raw score by the total number of items. So we have the operation card divide, and it's 0.6. And then we subtract 100 from base. Now we have a fixed constant here, which is 100. So in 004. So we have 100 minus 40, that's 60. Okay, and whatever we had divided before, we added it, we multiply it with 100 minus base. So we have 0.6 times 0.60, that's 36. And then 40, that's 40 now, that's a base, times plus 36, by the way, plus base. The grade is 76. Now we assume that it was a 0, it was a false, no, or it was a failing grade. And then we set up the condition. No, here's how it is. We load it 74.99, which is our computed, which is our cutoff. No, by the way, 74.99, which is our cutoff. We subtract the grade. It's 1.01. Now in here, no, the run-up lever will be 1. I'm sorry, no, na 0 yan. That will be 1. Okay. So what will happen here? This is like, if grade is greater than 74.99, okay, we skip here. We skip the print bell and hold. Do you follow? What will we do? Since this is a negative 1, no, we will skip four lines. So we will multiply 1 by itself. It's 1, and we store it as the result. Okay, which means that the grade is passing. Okay. Aspa and whoever came late, no, you just text, chat me, no, please. Now, if this were 74, no, 74, okay, this will be a 0, the run-up lever. So therefore, this will not skip, but it will just do a print. They follow, which means that the grade was really a failing grade. They follow. So which is the same in our grade computation program, like this, no? Ito, no? Parang if then else. This part is the part which is the if then else. Okay? Do you follow? So you can imagine the result or the invention of Charles Babbage, no? It's already a complete computer. Even Alan Turing himself, no, declared it to be a complete machine, which means that it can do computations, it can do repetitions, no, like loops, and it can also make decisions, like we do in a standard programming language. The only difference is, no, we don't have an if statement. We usually do an if using a minus, and then check if the result is negative. Okay, any questions? So your assignment on Monday, have you read it already? No, I've introduced it before. Okay. Your assignment on Monday is almost the same, but this time you extend the Fahrenheit to Celsius program. Okay? In that it's a temperature taken from a patient. Now, you output a 1 if the resulting temperature is equal or above 37.5, which means the person whose temperature is taken is having fever. Otherwise, you output a 0. Okay? So, in short, we can say that for loops, no, or while loops can be implemented in the analytical engine using CB, and if then else statements can be implemented using CF. Do you follow? Do you follow? So it's an amazing invention that, in the fact that it was 1637, and Charles Babbage was already able to figure that out, no? How to make looping and how to very advanced. Okay. Any questions? Any questions? Okay, so I have already given you, no, the descendants of Charles Babbage, and then ENIAC, the story of ENIAC. Okay, what was the discovery in ENIAC? The concept of accumulators. Okay, the accumulators being the ingress and egress register at the same time. Okay. Now, which brings us to a new machine. Okay, the stored program concept and the IAS machine. The stored program concept was first introduced in 1945, and the computer representing it was completed in 1951. Okay. Now we are introducing a new personality here. No? So remember, we were talking about Charles Babbage and Countess of Lovelace, Ada Augusta King. No. Then there was Eckert and Motley, Atanasoff and Berry. No. There's Konrad Zuse. And by the way, the pronunciation is Konrad Zuse. Okay, German. And then there was Alan Turing. You follow? This time we are introduced to a new personality, no? A very popular figure in the history of computing, John von Neumann. I'm sorry, sometimes the John is spelled with an H, no? Most of the time, no? Okay. Kasi from a different nationality, no? Now, the stored program concept was first released in 1945. The concept itself, no? In a report by John von Neumann, no? Entitled "The Draft Report on the EDVAC Computer." Okay, we'll mention that later, no? Okay, the IAS machine was developed in the Institute of Advanced Sciences in Princeton University. Princeton University is a very old and famous university. John von Neumann taught in this university from 1930 to 1933. And Alan Turing finished his PhD in math, no? Also in the same university in 1938. Okay, so very popular figures. And it introduced the stored program concept, no? In contrast to the popular architecture to that time, which was called Harvard architecture. So this architecture is called Princeton architecture. So there are two competing architectures. Okay, Princeton and Harvard. Okay, Harvard architecture follows the convention in the analytical engine, where the program and data are stored in the input device, separate, no? Okay, the program is in the input device and the data is in the store. Do you follow? Yun yung concept ni Charles Babbage. Any questions so far? So you have to distinguish the Princeton architecture from the Harvard architecture. Okay. Like the analytical engine, the IAS, Institute of Advanced Sciences, again, no, is a 40-bit word. Ba, 40 bits din yung kay Charles Babbage. But the strange thing about this is it uses 20-bit instructions in each word. Now, unlike in Charles Babbage, no, the whole instruction fits in the 40-bit word. Anyway, it doesn't matter because the program is in the it's in the input device. Do you follow? Now, there's a problem here because when programs are loaded into memory, no, a word can occupy 2 instructions. Okay, the word being 40-bit and the instructions being 20-bit each, which means that only half of the word is occupied by an instruction. So 2 instructions are fit into 1 word. So there's a left instruction and there's a right instruction. Usually, the instruction to the left is executed first. Okay. Any questions? Negative numbers were represented in 2's complement. Here's a comparison, no, of the analytical engine. I'm doing this to show the evolution. Okay. In terms of the number system, okay, the analytical engine uses 40-point fixed point decimal. Why decimal? Because of the rotating gears. The IAS uses 40 bits floating point binary. We will discuss what floating point is. The main difference between fixed point and floating point is floating point is more accurate. Okay, it can manipulate or cater to very small numbers and very large numbers. Okay. In terms of the processing unit, there are only 3 registers in the analytical engine. Now, in the IAS, the mill was split into 2 main functions. Okay? Unlike in the analytical engine, you have to distinguish this, no? Mathematical operations and execution of commands are done by the mill. Do you follow? In the IAS, the mathematical computations are done by an ALU, or an arithmetic logic unit. Okay? Any questions so far? Okay. And the program execution is done by a control unit. Okay. It has an accumulator register, like the ENIAC. And it has a multiplier quotient register and many other registers, which we will discuss shortly. No? For the input and output, no, the analytical engine uses Jacquard loom. And for the IAS, it uses secondary devices, most probably tape drives. No? Although it can also use most probably punch cards. Okay. Now, in the program execution, okay, the programs are loaded in the Jacquard loom in the analytical engine, and data are stored separately in the store. No, do you follow? The program is in the Jacquard loom, the data is in the store. Now, John von Neumann realized that there's something wrong with this. Can you point that out? Can anybody point out what's wrong with the program execution of the analytical engine? Anyone? Can you identify that? Can somebody? Yes. What's the main problem with that? Ang problema dito is, since the program is in the Jacquard loom, fetching the instructions one by one and loading it to the mill will be very slow, right? Because imagine it rolls 1 card at a time and it's done mechanically. It will be very slow, right? What if you will say we will change the Jacquard loom to a very fast hard disk? Will that solve the problem? Anyone? Tony? Will that solve the program execution problem if we are going to change the Jacquard loom with a fast device?
I guess so, sir.
Okay. The answer is no. Why not? Because memory is always faster than the hard disk, right? Diba? So if you run the program from the hard disk, it will be slow. But if you run it from the memory, it will be much faster. Right? I hope you agree. No? So anyway, what John von Neumann did is change the program execution. No? That's why there are two units. No? Programs before they're executed are loaded in whole, no? Not in part, in whole by batch from the secondary storage like your hard disk to memory. Do you follow? So nowadays, when you run an exe file, the exe file is from your hard disk. But when you click it, it will be loaded fully into memory before it's executed. Okay? That's called the stored program concept, which means that the program and the instructions are now in the same medium, which is the memory. Do you follow? I hope you distinguish that, no? Kasi in Charles Babbage's concept, no, the program is in the loom, and the data are in the memory, and so they're separate medium. For John von Neumann, let us store them on the same memory. Okay, instructions and data are both stored in memory. That's called stored program. Now, instructions are fetched sequentially from memory to CPU during program execution. Okay, so program execution composes now of two cycles called fetch and execute. Fetch transfers the code from memory into the CPU, and execute is performed. Execution is done by the CPU to perform the desired function. Okay, I hope you are able to recognize that, no? All CS students or IT, right, or computer studies students, no? If you're asked in a quiz bowl, what is a stored program concept? You should be familiar with this, no? Because it's still the same concept that you use when you are writing programs. Okay. Before I proceed, who are the latecomers? Can you chat me so I will identify you quickly? May mga latecomers, di ba? Hana Al-Qaeda. Haven't I checked you? Yes, I've checked you. Litob. And then Aspa. Kent. Anyone else?
Bumaat po, sir.
Bumaat.
Dwight Bumaat.
Anyone else?
Thank you po, sir.
Campus po, sir.
Campus. Anyone else?
Tan, sir.
Tan. Okay na. Okay. James Paul. Okay. Now, before we proceed to programming of the IAS, which will be your next assignment, not today anyway, no? Let's look at the IAS computer diagram. Ito yon, no? If this were the analytical engine, this is called the mill. This time, no? The processor or the mill was split into two parts. You have a data processing unit, or sometimes called the arithmetic logic unit. Okay, the arithmetic logic unit does the arithmetic. Okay, addition, subtraction, multiplication, division. Okay, it has three registers: AC for the accumulator, MQ for the multiplier and quotient. Okay, during division, this stores the div quotient. No, div multiplier quotient. The divisor. I think this shows is used for the divisor, no? And then there's a buffer register, which is usually used, no, to as the second parameter, no, transparently. So the arithmetic logic unit does the arithmetic operations. Yeah, the program execution is done by the program control unit. It has an instruction buffer register, IBR, and memory address register. The instruction buffer register is used during the fetch. Do you follow? When an instruction is loaded from memory into the CPU, it goes to the instruction buffer register. And the instruction buffer register is further split into two. Okay? Because the instruction contains two parts. Okay? An operation and an operand. No? An operation or the operation card, no? And the operand, whatever is the parameter. The instruction goes to the IR or instruction register. The operand goes to the memory address register. Because remember that when you have L001, 001 is the address, right? Do you follow? L002, 2 is the address, so it goes here. And L goes here. And 002 goes here. Do you get my point? Okay. Another competing architecture during that time was EDVAC. Okay. Now, EDVAC and IAS were released both in 1951. IAS was just released slightly ahead of EDVAC. And then, during that time, no, Eckert and Moakley from Penn State wanted to get a patent for ENIAC. Okay. They did not want to get a patent for EDVAC. Why? Because in 1945, no, John von Neumann published, no, the first draft report on EDVAC. Okay, where he detailed the design and the stored program concept. Do you follow? No? This is the controversy. No? The preliminary report was the source of acrimony between the factions of the EDVAC design team. No? Kasi they're trying to get the credit on who really is the author of the stored program concept. Okay? So there were rumors, no, that Neumann just got it from a group discussion, and anyway, anyhow, no. To make a long story short, Eckert and Moakley did not contest the first draft report on EDVAC. And later, when they were sued in court, no, for the patent of ENIAC, the court removed the patent from them. We will discuss that later. No? So, John von Neumann was accredited the inventor of the stored program concept, and then the inventor of the first electronic binary computer in the US, no, was accredited to Atanasoff and Berry for the ABC computer. Okay, it was taken out from ENIAC. ENIAC was supposed to be the first, no. Okay, and it's a very long story, no, because it had a sequel, no? How IBM became a tech giant. We'll talk about the sequel later. So EDVAC is also another important discovery. It's easy to remember this if you know the story, no? So malaman mo naman if you know the story behind. So from ABC to ENIAC to EDVAC to the IAS. Let me edit first. Okay. So much for EDVAC. We will proceed with how to program the IAS and try to illustrate the evolution of programming from the analytical engine to the IAS. Okay. I will give you exercises on this next meeting. Now, the IAS instruction set. Can you see this?
Yes, sir.
So basically, the IAS has data transfer instructions. Okay, like in the analytical engine. So you see, there's already a close resemblance. There's also a load and store. Okay, the most important store, a load, is load mx. Ito, load mx. We load a value in the stock in the memory. Load a value of address x from memory to the accumulator. You follow? Diba? What is our load in the analytical engine? Load to ingress access 1, the first load. The second load goes to ingress access 2. Right? But here there's no question whether where it goes. It only goes to one register. Because only one register is used both for input and output. Berdin, you okay? So latecomers, you chat me, no? So I can just go on. Okay. So there's no ingress access 1 or ingress access 2. So the sequence is not important. So when you say load, it will automatically load to the AX register or AC. There's a load negative, which will convert it to negative before transferring to the accumulator. Load absolute and load negative absolute. However, there's load MQ, which transfers MQ to the accumulator. You follow? So all loads will go to the accumulator. Except this, This. However, we will rarely use that, We'll use the normal load. Now you see, there's an opcode. Because this is a binary computer, when you program them, usually programmers use the opcode in binary. But in writing the program, you write the program using the symbolic representation. Okay? Now there's a unique jump, which means unconditional jump. You can jump to a specific location in memory. Now, the unique thing about this is it's not just an easy jump. There's jump M left, jump M right. Okay? That's because an address can store 2 instructions. So there's a left instruction or a right instruction. Although, during the normal execution, the left instruction is executed first. Do you follow? So during a jump, you have to specify whether jump to the left or jump to the right. Okay? Any questions so far? There are add, sub, mul, div, left shift, right shift, similar to the analytical engine. Okay? Okay. However, there's a jump plus, and jump plus to the left or jump plus to the right of a given address. Now, what does it do? If the number in the accumulator is non-negative, okay, do the jump to the left. Or if jump to the right, if the number in the accumulator is non-negative, do the jump to the right. So what can we say about jump plus comparing to the analytical engine? What's the equivalent? The good thing about jump plus, in the analytical engine, there are two jumps, no? Forward and backward, no? When you want forward, you say CF. When you want backward, you say CB. Right? Di ba? Dito, jump can either jump to a previous instruction, which jumps backward, or jump to a succeeding instruction, which jumps forward. Do you follow? So, isang jump lang. So, it's like the CB. However, if you want to translate your factorial program by substituting CB with jump plus, you will be desperate. They are not exactly the same. Anyone? Why? And you know why? Anyone? That's because jump plus will jump if the value is non-negative. CB will jump if the value is negative. So they're converse. Diba? CB will jump if the value is negative. Jump plus will value if the jump plus will jump if the value is non-negative. So there's a problem there. Anyway, we will solve the problem. No? So there's store and store instruction to the left or store the instruction to the right. Any questions so far? So that's the instruction set. Now let's have an example of the IAS programs. You can download this, no? Any questions so far? So we'll trace this now. The first program is the Fahrenheit to Celsius. Okay. Let me explain this. Why is it like this? No? Because now the program and the variables are both in the same location, diba? They're in both in memory, right? Unlike before, the program is in the Jacquard loom or in the input device. Okay. This time, we load them first in memory, so they are located in the same with the same series of addresses. Okay. So ito yon. Likewise, we have the variables M0, M1, M2, M3, M4. Okay. Now we only have the accumulator register because it is both used for input and output. Okay. So we have the command addresses 0, 1, 2, 3, 4. Now when we reach 5, we have two addresses, 5L and 5R, because 5R is supposed to be here, but we cannot write it that way. No, because when we trace a program, we trace it sequentially. No, we don't do it. We do it vertically, but we don't do it horizontally. Do you follow? Okay. Now, there's a micro instruction here, which explains the data transfer. When you say load M1, we mean AC receives M of 1. The arrow points to who receives. When you say store M4, M of 4 receives AC. Okay, when you say sub M2, AC receives its value minus what is in M2. Store M1, which means M of 1 receives the value of AC. Okay, do you follow? Okay. So ganun yung ano, let's okay. So anyway, let's trace this. This is a translation from the analytical engine. Okay, take note, no? Load, store. Pero isang load lang because we only have one register. the first command is a jump to the no, to the 5 because usually data is stored at the beginning, no? And after the last data, we have the first instruction. Now, nowadays we call that the data segment, which is in the first part of the program, and the code segment, which is in the latter part of the program. The code segment stores the data, and rather, the data segment stores the data or variables, and the code segment stores in the instructions. Okay. Any questions so far? So let's trace this. So when we say 4, 1, 1, M of 1 contains 4, M of 2 contains 1, and M of 3 contains 1. I think our partial product is stored here. No? We'll trace that anyway. No? Okay. So load M1. When we say load M1, we are going to load the accumulator. What value is stored in the accumulator? Anyone sino yung last dumating? Pusta. Pusta, are you there? I'm sorry.
Yes, sir.
Sandali lang ha. I'll have to check your attendance. Okay. When you say load M1, what value is loaded to the accumulator AC? Tisha,
Accumulator.
come again?
Sir, is it still the first value? Like yung analytical machine, so it's 4.
Yeah, the same. It's like the analytical engine.
Okay, sir.
Diba? Pareho sila, no? Pareho sila pag-address ng memory. So it's 4.
Yes, sir. Thank you.
And then store M4, which means that what is in the accumulator will be stored to M4. No? So where will the value 4 go? Alcaide? Are you there? Zion, Joshua?
Yes, sir. The M4 becomes
M4.
4.
It's just like the analytical engine. So there's the evolution. No? When we say sub M2, okay, how much will be subtracted from the AC? Jam, Makiling, are you there?
Yes, sir.
Okay. The current value of the AC is 4, right? When you say sub M2, how much will be the result in AC?
3, sir.
B, because M2 is 1, di ba? Okay, thank you, no? And store M1. Where will the 3 be stored? Larombe?
M1, sir.
M1, very good, no? So it's just almost the same, no? So anyway, let me go through this. Mul M4, so AC is now multiplied with M4, so 4 times 3, this becomes 12. And store M4, this becomes 12. Okay? Any questions? And we have load M1, which is 4. No? A load M1 is it 4? Is it no, it's 3. No? Okay. Sub M2. M2 is 1. So this will become 2. And store M1. So this is now our next multiplier. Okay. Any questions? Then we have load M4. M4 is 12. Mul M1. M1 is 2. So this becomes 24. Store M4. So we will store it here. Okay. Load M1. What's M1? 2. We compute the next device multiplier. Sub M2. M2 is 1. So this will become 1. And we store M1. This is our last multiplier. We load M4. So this becomes 24. Mul M1, 24 times 1. This becomes 24. And we store it here. And we have 24. Reason. Any questions? Now, the halt is done using a jump to the same address. Who's last? Reason? Okay. A halt is done is using a jump to the same address. Jump 14L. 14, 0 to 19 is left because 20 to 39 is right. Right part, no? Any questions so far?
Sir, na ako'y question.
Yes.
Katong sa pinakataas po, katong mag-start ka sa AC to M1 kay first value jud imong gamiton. So for example, mag-create og
Dito,
ako
dito.
so bawa
Is this here?
with kana sa sa first kaning load M1
Yes.
So first number imong ibutang dira sir halimbawa si 4 sa M1 nga na ay
No.
alagi.
We converted this from dito sa kay analytical engine.
Dira day nakita na nako.
Di ba? Sa analytical engine anong una? L001. Let's open that, no?
Nakita na day. So M1 is for
Yeah.
the distor size. Okay.
Pareho lang ito sa sa analytical engine. Di ba? Kaya lang we only have one load because we only have one register. Okay? But the logic is the same as the analytical engine. In fact, I have just converted this. Okay? Tulyo ba yan? Okay? So if you do I have to compare this? Ito yung fourth factorial sa L002. By the way, binaligtad ko pala yung posisyon, no? L002 and then S002. Ito pala yung una, no? L00 and then L001, okay? The positions of the variable may be different, but the logic is still the same. Okay? Okay, Fahrenheit to Celsius. It's the same logic, no? We'll just have a jump here. Jump to the left. Okay? Next meeting, we will discuss looping, no? So 132 is in M1, 32 is in M2, 5 is in M3, and 9 is in M4. And our result will be on M5. Okay? So we jump from 0, we jump to this. Okay? Load M1, AC becomes 132, right? Sub M2. Okay? So M2 is 32. So 132 minus 32 is 100. Okay? Mul M3. M3 is 500. 5, no? 5 times 100 is 500. 500 divided by 9, which is M4, is 55.556. And then we store it here, and then we halt by jumping. Now take note, no? This is jump to the right, 20 to 39. It loops there. Any questions? Same logic, no? And then we have meters to feet. No? 4 meters we convert to feet. So this is, by the way, 4. This is 3.28. Okay. So we load M1. So AC receives 4. And we mul M2. This is 3.28. No? So it becomes 13.12. And we store M3. This is the result. And then we jump to the we don't have a keyboard. We don't have a mouse. We don't have a printer. We don't have a monitor. No? Unlike in we have a print in the IAS. or rather in the analytical engine. So I will show you your next assignment, no, but it's not yet due, no. Ito 'yon, okay? Mahirapan tayo sa looping, no. I will give this formally on Tuesday. Okay. Write a program to compute the sum of the first 4 numbers. Oh, we know this already, no? For the IAS and store it to sheet 1. Exercise 3 na ito, no? And then write a program to convert Celsius to Fahrenheit. And then write another program with loop this time to compute the average of the first 3 numbers using the IAS. Okay? Any questions so far? So I'll show you this on Monday, or rather Tuesday, no? So that's another 1 week assignment. Sino yung last dumating? Who was the last one who came in? You can download the worksheet, no? Anyway. Let's get
Sir,
yes.
is Mr. Berdin present po?
Yeah, Berdin nga yun. I was asking. Anyone else? Advincula? Chris Maynard Ampon? Rafael Vince Fernandez? Daniel Gallego? Angelo Gomez? Stephen John Jimena? Cheyenne Kersoloff? Joas Miguel Deito? Alim? Jar Ashed Morandante? James Polpol? Okay. So that will be up for now, no? No other new lessons. Okay. Next time we will discuss the exercise to be done on the IAS, and I will tell you the story behind the controversy, the controversy behind ENIAC. Okay. And the beginning of IBM. Okay. Any questions? So that's up for now, okay? We'll dismiss the class.
Ay, sir, mag-meet tayo bukas.
Wala tayong meeting every Friday, no?
Okay po, sir. Salamat.
Okay, thank you. Any other questions?
Sir,
Yes.
curious question lang nako ha regarding sa IAS. Unsay kaning binary base niya sa number system niya?
Base 2,
Base 2?
Yes.
Okay.
not base 10, okay? Base 2. We will discuss binary numbers, no, in one of our future sessions, no, when we deal with Boolean algebra and binary number conversion. Okay, that's part of our syllabus. Okay, so unlike the analytical engine, no, the analytical engine is base 10. Okay, the IAS is base 2. Do you follow? Any other questions? Okay. Thanks everyone. No. See you Tuesday. Okay. Bye everyone.
Thank you, sir.
Thank you, sir.
Bye, sir. Thank you.
sir.
Bye, sir.
Thank you po, sir.
Thank you po,
Goodbye
sir.
po.